Hello, everyone, and welcome to Genius Machines. I am Patrick Tucker, Science and Technology Editor for Defense One. We are very excited to kick off today's program with Mark Munsell, the Director of the Data and Digital Innovation Directorate at the National Geospatial Intelligence Agency. Mark, thank you so much for being here.
Hey, thanks, Patrick. Really happy to be here.
Thanks. So, real quick, just a couple of words about you and what you do at NGA.
Yeah, so a few years ago, we stood up a new directorate in data and digital innovation, as you said. The focus of that directorate was really to usher in artificial intelligence into the agency, and to the national system of geospatial intelligence, the broader system, and to make sure that our data pipelines, our data engineering, our data science tradecraft was set up, ready to go to be able to usher that in. And so in the last 3 years, we've really established a lot of that infrastructure inside the agency to include governance, responsible AI. We've established a chief data officer. We've established a chief data scientist role, and basically have hired data scientists, data engineers to be able to sort of build out and create the environment to be able to bring in artificial intelligence into the agency.
All right, awesome. So one of the aspects of bringing artificial intelligence into the agency in April of 2022, there was a big announcement at GeoInt out near Denver that a very key Pentagon AI program, kind of the flagship program for AI applied to intelligence collection to aid and analysis, Project Maven, was going to transfer over to NGA. And you gave some talks at the time, and you described your priorities for Project Maven under NGA, getting people on the program, getting leadership in place, setting up a program office structure. And in terms of technology, you described a lot of enthusiasm about capitalizing on the department's investments over the last 5 years. So really quick update on from April 2022, this announcement, to now. Where are you on meeting some of those priorities?
Yeah, so we brought Project Maven in January of 23, officially transferred the project to NGA, stood up the program office, like you said, hired the team to sort of lead and run it. To be honest with you, we had been working with Project Maven since 2017, hand in hand. So we had already had a good running start at this. We had already been providing imagery and video and data sets and training data and expertise to the project all along when it was in the Pentagon. So when it finally came to NGA, first of all, it made a lot of sense because most of Project Maven was geo-intelligence focused. And that would be full motion video from ISR sensors or satellite-based imagery from our commercial and national sensors. And so bringing that into the agency was natural. It was the right thing to do. We brought it into an area of the agency that had already been practicing modern software engineering, DevOps, and now machine learning ops. And so culturally, the agency really kind of embraced it, took care of it, turned it into a program of record. That's a really important point I'd like to make. So it went from a project, a sort of a research project or a pilot project, to an official program of record where we are utilizing what's called the Department of Defense software pathway. So it's not a traditional program, but it's an advanced program that uses the software pathway acquisition technique. And we're very happy to say that it's a healthy program, that we put together a healthy program office, and that we are very quickly advancing the adoption of Maven across all the combatant commands inside of NGA. I'd like to ask our folks two questions. I'd like to ask them, what has NGA done for Maven? And what is Maven doing for NGA? When we bring those two, we ask those two questions to the group inside of NGA, the conversation really turns to a flourishing, positive conversation about the benefit of bringing that program into the agency.
I want to go back to something you just mentioned, the software pathway and program of record. So congratulations, of course, on creating a program of record out of a project. A lot of times when I cover programs of record and they apply to tanks and ships and jets, what you find is that where there was nimbleness in building a prototype and contracting. Once it becomes a program of record, then you get a lot of bureaucracy, and then things in terms of innovations tend to slow down. But what you're describing sounds very different. Talk about how, as a program of record, you're employing this software pathway to keep it innovating, so it's not like a program of record that buys software like like a ship, but instead buys it at the iterative scale that is information technology.
We're very proud of being one of the few, actually, we were the first AI software pathway program in the existence of the Department of Defense. So we're very proud of applying this new modern software engineering technique and acquisition technique to this particular problem set. A couple of key metrics, I think, that I'd like to share with you. While we have big requirements, we have sort of big North Star requirements about the big things that we want to do over the years. It's very important that we iterate on software very fast. And I'll give you a metric. We deliver thousands of software updates to Maven a week, thousands. And that's a metric that your most modern software engineering companies have. They, perhaps they deliver more. Facebook probably delivers millions of software updates a week. But, this is the first time in the Department of Defense where we're really practicing DevSecOps for real. We can deliver new updates. We're constantly doing security patches. So it's a very healthy software engineering organization, and we're very proud of that.
So when I think of Project Maven, I'll go back to the story. We actually broke the story on Project Maven, and at the time, it was sort of described as AFSOC, Air Force Special Operations Command, was the lead sort of public face to it. They're the ones that were talking about it. And the data collection was driven primarily by UAV platforms that could perform persistent surveillance over the Middle East. You didn't hear too much about space-based assets. And that just could have been because of who was giving the interviews about Project Maven at the time. But bring us through our understanding of Project Maven from its early days as this tool to do analysis on just the hours upon hours upon hours of video footage that was coming primarily from drones to track and watch specific targets, counterterrorism mission across the Middle East, to where it is today. What's the picture of it today that you're working with?
Yeah, Patrick, I think, if you look back on those missions and you ask anyone that was working to exploit those missions, it was a very tedious job. Mission could be 12 hours long, right? And you'd have the same crew sort of exploiting that mission the whole time. And that would be putting eyes on those video screens for that entire time, using the sort of human cognition to see and recognize things that are on the video, be able to verbalize or document via chat or text or reporting or PowerPoints what's happening in those videos, to the point where, it was untenable. The amount of people, the amount of time, the amount of energy, and sort of tedium that an exploitation crew would go through. So it was a simple idea to say, hey, look, we look at Ring doorbells, we look at video cameras that are that the police use on the streets, and they're using AI technology to recognize entities and objects and vehicles, and then they're able to track those vehicles. And so, as a simple proposal, why don't we use similar technology, artificial technology and computer vision technology that was developed by Silicon Valley, and apply it to military missions? And, that's what the Pentagon did. They got started on it, some level of success doing that, taking some of the tedium out. But then, of course, we were able to apply similar techniques to other video, other imagery, other ISR technology, and it was as simple as transferring those artificial intelligence models to low Earth orbit, taking a lot of, again, commercial technology, things that were developed by commercial satellite business, and basically transferring that to a new modern mission.
Yeah, and you can see the essential nature of doing that. It always strikes me as funny when people describe the Middle East as a permissive environment, because a regular human being has associations with the word permissive that you wouldn't necessarily apply to the tempo of operations in the Middle East. But nevertheless, when you're talking about some of the great state adversaries, the large high-tech adversaries that the United States is trying to deter today, the possibility of flying drones over areas where we need to keep watch is very difficult. And that is why space is becoming just so much more important to everything that the United States is doing in terms of watching adversaries and planning what to do next in order to better deter. So you can see the importance of that evolution from a variety of platforms that are maybe UAVs to a movement towards space.
Yeah, Patrick, I think you're tracking the proliferation of satellites is growing, and from our commercial vendors and other partners that are out there, the National Reconnaissance Office, essentially, we're going to have a lot more source material, a lot more sensors in space, and a deluge of data that the only way that we can use that information is through automation, and in this case, in particular, computer vision and artificial intelligence.
Right. So on that, let me ask what we can now do with that data that's maybe a little bit more ambitious than people were thinking about when the program was first launched. There's a lot of people today that are talking about the prospect of satellite imagery in the hands of great analysts, and those analysts are using great tools to essentially arrive at an almost predictive capability to know it's not really predictive, but it will feel that way, where an analyst is able to, through tipping and queuing, detect an area of significance before it blows up into a crisis, into conflict, into a geopolitical mess that then everybody has to suddenly orient around, essentially seeing the bang before the gun goes off in many ways. Watching, for instance, trends in drought, in agriculture, in construction, and things like that, as a means of understanding where there's going to be a lot of activity that the U.S. has to watch. So this is something that folks at Planet, I know at Maxar, at some of the other big satellite imagery providers are talking about more and more, wanting to arrive at. And I just want to get your thoughts on that. Is that part of the future that you imagine for Maven?
It's absolutely the future. Essentially, you use a sensor to detect what's happening on the Earth, and based on that detection, you can either use it solely to inform future collection, or you can fuse it with other information. You can fuse it with open source information, news reporting. You can fuse it with what we understand about the area, the activity in the area, and you can then have new insight that will tip and queue new collection. So it's just a cycle that's in constant improvement of itself, and we've seen both higher quality tipping and queuing, higher quality detections, which in turn will reduce the time frame in which an activity happens to the time frame that we actually can visualize it or observe it, to the time frame that we take action.
What are, to the extent that you can talk about, I don't know if you can, how do you characterize those time frames in terms of what was possible a few years ago, maybe 2016, 17, to what's possible today?
Well, several factors, right? One of the factors is the number of satellites that you have, right? That will decrease the amount of time. The other factor is the quality of the artificial intelligence model's detections. The higher the quality of those detections, the higher confidence you have in reallocating your resources to do further collection. And then if you have high confidence detections, you can take action faster. So I can't really talk about too much about all of those sort of vectors that are going into this mix, but least I can say is the magic formula here is better sensors and more of them, higher quality artificial intelligence algorithms and models that detect higher quality positive identification of objects of interest. And then the third piece is to do it as fast as you possibly can. And so, that includes having the compute power to run these models, to run ubiquitous models, to have hundreds or thousands of models that are orchestrated by other models to do it as fast as you possibly can, so then you can go through the cycle again and again and again.
Yeah, and these are all areas that are expanding rapidly. You just mentioned the massive proliferation of objects in Leo that can do collection, an explosion of potentially available and more easily structured types of data. I know that there's new startups that do radio frequency collection. You can do that from a lot of distances. There's, of course, tremendous capability now to actually move open source data into where it needs to be like a part of analysis. We're surrounded all the time by new breakthroughs in AI models that, in terms of what the consumer sees, they're sort of like fun. But in terms of what science is showing, when you apply these models to well-curated, well-understood data sets, it really actually is quite remarkable. So these are all areas that are growing really quickly, and that suggests an almost exponential increase in the ability to accurately and quickly reach new analyses and predictive analyses about things to happen. Is exponential a possibility?
With the sort of advancement of generative AI, the advancement of foundational models, right? A lot of people refer to them as large language models. They're very quickly becoming multimodal models. You might have seen like the large vision models that OpenAI came out with, GPT-4V, V for vision. And essentially, what's happening is, in the sort of rapid pace of the improvement of the quality of these models, pair that with, in our case, the intelligence community's exquisite data that we have. I mean, that is a differentiator between what OpenAI trains on the open internet, right? The corpus of the internet, the humanities, for good or bad stuff they put on the internet. But now think of the exquisite information that the intelligence community has, where we can fine tune these models with that. I think we're looking at something very special. In fact, I think our agency is sitting on a gold mine. You can imagine we have petabytes and petabytes of images of the record of the Earth. And we have millions and millions of analyst reports about those images. What we're sitting on is this gold mine of multimodal data that Google or YouTube or Amazon would love to have, and where we can fine tune one of these large foundational models and really have something special in the future here.
Yeah, let's talk about that for a second, because some of these models, large language models in particular, they've certainly caught a lot of public enthusiasm and imagination. When I talk to folks in the national security community, in particular at the Pentagon, recently had a conversation with Maynard Holliday about it, the head of the Critical Technologies Office, kind of a key player behind Task Force Lima that was looking very specifically at how the Pentagon might use some of these generative new AI tools, the ones that are very buzzy right now, large language models in particular. They point out how important it is to understand, to make sure that within the context of the Defense Department, you know what your data is. You have very good curation, control over your data sources. And of course, that's going to lead to insights that are, as you point out, more credible than when you apply a large language model to all of the all of the internet, which, as we know, is full of people that don't necessarily have the best idea about things. Can you talk a little bit? I don't know if it's connected to Project Maven exactly. It might be something that you're thinking about more broadly, but how large language models might change the life of the analyst and further accelerate analysis products. Where is there opportunity? And in terms of that partnership between an analyst and a tool, where is there some room for caution?
Yeah. So we're very optimistic, like the rest of the community is, on what these models can do to assist our analysts, right? I mean, it's obvious to us, either from sort of reading through thousands of documents, maybe reading through millions of historic reports that analysts have made, and having the large models concisely bring up the most important information, and to bring that to analysts' views right away, for them to sort of sift through and or summarize and or use in reference of the analysis that they're doing. There's great opportunity there. Combine that now with the computer vision models that we've had running for some time, where the computer vision model might be detecting certain things, and then the large language model or the foundational model can take those detections, summarize those, and or infer other activity. Like having it, it's like having another analyst sitting next to you working on a whole, another piece of work that's part of your workflow that you don't have to worry about while you're concentrating on things maybe that the models aren't good at. So there's a program inside of NGA that specifically is designed to use AI to increase analytic productivity. It's called Aspen, and it's several different applications sort of coming together to make analytic workflow faster, better, and easier. So I think it's going to be quite disruptive. I think how some of the early adopters use it will be a great test case in terms of what we should be using, what we shouldn't be using, how we should test it. What are the tenets of responsible use that we have? While industry is very concerned about personally identifiable information, medical records, privacy, ethics, obviously those are all very important to us as well. But when you take our work and how critical it is to inform policymakers and commanders in a timely and accurate way, it kind of we take it up a notch in terms of what we look for in terms of responsibility and safety. So one of the things that we've developed here at our agency is a responsible AI program, and specifically a training program that puts our analysts and developers through the paces, actually runs them through scenarios of potentially irresponsible use of artificial intelligence in our jobs, and make sure that they are applying artificial intelligence in an ethical and safe and responsible manner.
When did that start, the responsible AI program?
So it started with a training program that just kicked off in April, and we ran a couple of pilot classes with developers, and now we're starting the same classes with users, so analysts. So it's only a couple months old, but we're very proud of getting it started. We're very proud of our Chief of Responsible AI, Dr. Anna Rubenstein, and I'd recommend sometime in the future that you have a good chat with her.
I would love to. I love to talk to responsible AI people. It's actually my favorite people to chat with. They don't always get that reaction. Sometimes they're like, "Hey, I'm the responsible AI person," and sometimes I don't know. They don't often meet an enthusiastic conversational partner. But I'm happy.
A lot of people want to talk to the irresponsible AI person, right? Show me that person. I want to talk to them. Yeah.
Yes, that's right. I do like talking to irresponsible AI people too, but I'm not sure I'm going to give them the keys to the car, So I want to go back to some of the other ways that some of the innovative companies in this space are also trying to do more with AI. Recently attended a event by Planet, and at the beginning of June, they announced a partnership with NVIDIA. They want to take NVIDIA GPU units and onboard them on next generation Planet Pelican satellites to kind of create a small capability for AI to happen in space on a satellite, some rudimentary AI processing of imaging that can then send back down to Earth. It's sort of like the first stage of that analysis process is done by the time the thing actually hits the ground, and that they feel can really maybe accelerate that analysis project a little bit more. And the idea of satellites that have AI on board is sort of fascinating to me. What do you think of this idea?
Yeah, I think it's the natural next step. And I think companies like Planet, they can have more satellites. That's kind of Planet's thing, right? We have a lot of satellites and try to image the Earth every day. And they can generate more pixels, more images. But unless we have people to sift through all those images, it falls on the floor. So it's a logical next step for commercial satellite companies like Planet to innovate in the area of, can we develop good models and run those models on board so that we can derive, important, insightful information without having to send the image down? And because it takes time and it costs to form that image in terms of compute. and send it to a ground station. So this is a logical next step. And I think it's good for the community because it will advance it'll advance the commercial satellite vendors to make better models, to run them more efficiently, to have higher quality detections. So it all overall, it's a very smart idea for our industry partners to move toward that direction.
And they're also talked, and this comes up between a couple of different vendors. I think Black Sky is doing this too. The need for mesh communication and networking in space so that you can kind of keep, for instance, like a task order in place even as different satellites are moving. And that way you have like a series of satellites that are kind of communicating with each other about how to make sure they keep custody of that, oh, I don't know, that ship in the Black Sea that's turned off its AIS responder and is trying to evade, detection and things like that. Mesh networking, mesh communication between satellite constellations in space. What are your thoughts there?
Yeah, again, another natural next step. I think all of this is going to drive more compute, higher bandwidth, more processing done in space. It's analogous to, again, a Ring camera. So you're not going to have your Ring camera download it to your computer to do the processing and then 5 minutes later turn around and tell you what's happening. You want it to do it as fast as possible, and you also want your Ring camera to mesh with. Amazon pays us for this advertisement, but you also want your Ring camera to mesh with the other cameras in the area, so that they all can benefit from knowing the activities that are happening across the board. So it's just to me, it's just the natural extension of what's happening in industry. It just so happens to be happening in low Earth orbit.
Yeah. So at Amazon, if you're watching, you always not mark us. So one last question for you though before I let you go. Thank you so much for spending some time with us to lay out all of the really interesting work that's going on over both at NGA and across industry in terms of just better understanding how to make sense of the world. But NGA and industry partners and the United States are not alone in this effort to do more with space-based intelligence, space-based image collection, increase the pace of maneuvers. China and Russia, but particularly China, has been incredibly robust in terms of launches, especially this year, putting more and more observable and observing objects into space to also kind of do what you're describing. Can you give us a sense of but in great state competition within your realm, applying next generation technology to image collection and analysis? What are your key concerns in that competition? Is it Chinese use of generative adversarial networks to create fake images of the Earth? I know that this is a kind of long-standing concern, the kind of deep fake issue. Is it something else? How do you see China attempting to, for their part, outmaneuver, and how do you respond?
I think with all new technology, all new technological breakthroughs like this, it elevates usage across the board, right? So all countries, all allies or adversaries are all looking to use this to gain advantage. And it's analogous to the cyber warfare effort. Somebody invents a faster supercomputer that can hack other computers or decrypt them faster. It's obviously an escalating. It's escalating in nature. So with China in particular, I see them looking at each category, like you mentioned, more sensors, more capability, more better algorithms. I think they're trying to excel in everywhere that we are as well. I will say this: the United States of America has the best commercial companies working on this. We have OpenAI, we have Anthropic, we have the people that have invented this and are now enterprising enough to be able to apply this to almost all commercial domains, all business domains, and all defense domains as well. So it's a great opportunity for the United States of America to leverage US-based companies to make our national security better and safer.
Okay. Thank you. Mark, for talking with us today, sharing some of your insights. I think that gives us a great window into what's going on here on Earth and also in space, and how quickly this competition is moving. It's very exciting, so everyone should continue to stay tuned. It's a long-standing area of coverage for us at Defense One, and it certainly will be growing in the future. Up next, I will continue today's discussion with Bill Strelin from the DoD's Chief Data and Artificial Intelligence Office, so stay tuned. Thanks.